How's it going, everyone? Welcome. Euler Gonzalez here. So let's go to look at the rendering logic here, uh, where the idea is to understand and be able to describe is the CSS fundamentals, right? So I'm gonna make a very quick overview of how do we get here by first look at the CSS fundamentals from MDM, which tell you what CSS is, how you can add style sheet, external style sheets, how you can even now add inline styles, and cherry picking elements from the DOM. And how you can do that is by using a special selectors, pseudo elements, pseudo classes, or to create selectors that when it comes to apply certain rules to that, we can use some of the convenient CSS functions that the language provide. And that is, well, for example, is the calc or cramp or color or HSL, especially instead of color, SSL, RGB, so on and so forth. And so how now the CSS will behave in a particular scenarios using now the add rules. And what are the rules that needs to apply? So for example, we view transition or layer or media queries and the shorthand property to describe now the box model, which is the way of how CSS actually look at each one of those elements as a box. And these boxes are made of now several layers around the content that you have now the content, you have the padding, border, and margin, which is the anatomy of the box model, something that we're going to describe here later on. But also the comment. This is the foundations of the CSS. And then now, what are the things that are still relevant despite that we have all of this CSS and JavaScript modern toolings that simplify is the selection or the creation of our selectors, which is, well, it is important to us for understanding is what a CSS rule is, the anatomy of a CSS rule. Also is some particular topic that is still relevant. So for example is media queries. What can we do with media query? What media queries are, and the uh, unit or particularly the selectors, okay, like pseudo classes or pseudo elements, pseudo classes like hover, focus, and the nth, first, and last child, or end of type, or first or end of type, okay, and how now, okay, as we make that, we realize that with the this pseudo classes, which also, for example, in the case of focus, is important to understand why this is still relevant, especially to provide now context or content for these assistive technologies, whether it's screen readers, for example, right? Instead of using area, why we use is now things like a wrapper from React, which is again go beyond the scope of today's. But in any case, we look at the media queries, we look at the CSS selectors, the anatomy of the CSS, the media queries, the selectors like pseudo elements, pseudo classes, like I mentioned before, pseudo elements like before and after, the placeholder, and also the uh, the combination of the selectors, uh, the units that we can use that are still relevant in CSS 2025 development, such as, hey, Well, the M or RAM or pixels, and when can we use each one of them, as well as the percentage and what and when can we use that. Now, it is that, for example, in the case of percentage, which is something that can we use as calculating is the width, which is what we're going to talk about in today's video. So the width algorithm is one of them, or calculating is the aspect ratio in that regard. So, but in any case, the idea is that as we now look at other things that are important, like the color, what are the type of formats that we have in color, which is a huge universe in itself. So we have now the keywords, RGB, hexadecimal, and HSL, and why is useful use the HSL, and how can we use that. Also is the typography, which describe is what is a font family, why we use font family, what are the type of font family that we can have. So for example, serif or sans serif, what each one of them determine or means, and when it comes to provide now any unique experience, how can we use now web fonts, which is customized or is uh, personalized fonts families, all right? And this is, for example, true in the case of Airbnb that is using now is Cerealial as the font. And so anytime you see that particular font, you see, oh, this now is part of this brand. So this is also why web fonts are used for this particularly branding to provide to your web app, and what are the anatomy of this web fonts or the typography, which is the type of fonts that we can have, or the variants of fonts, whether it's italic, whether it's strong, what each one of them means. The other is the look at the the type, the text transformations, uppercase, lowercase, or camel case, text spacing, letter spacing, or the text or line height or text spacing, whether it's vertical or horizontal or vertical, okay? Vertical with line heights and horizontal with letter spacing. And how now this is using behind the scene is a recommendation from the uh, web content guidelines accessibility, which say, hey, the space or the line height between this font must be 1.1 across different line of text. This is also important why we look at things, what we need to understand about the web content accessibility guidelines. So also, I look at this thing called the text spacing or a text alignment as well. So all of this, just to describe briefly, is the fundamentals as well as what are the things that are still relevant in 2025. And I do find that quite very interesting. Now, when it comes to actually go into the root, so understand now the way of how CSS is being processed, aka the rendering logic by the browser. So first thing first, we describe that any browser has a built-in style sheets known as the user agent style sheets that they provide now this custom way of looking all of these elements. So this is now a base definite, or this is the baselines, the design baselines for all of these elements. And because this was something that is particularly for browsers, right? Whether it's Internet Explorer, which is no longer here, but Edge, Firefox, Chrome, you mentioned, right? And because of that, Well, it turns out that it becomes now quite a pain for developers to have a baselines to that. So to have now a consistent design across different browsers. Because of that, we have now things like CSS resets, which focuses on that to say, hey, let's go to now make all the browsers user agent now start with this, okay, and then on top of that we can define all of these elements and the look and feel, so on and so forth, right? And since the way of how you can pass all of these different declarations or values is through the inheritance, pretty much like if you come from JavaScript or Java, when you want to have access to property and methods, you inherit that as a way to make your life much more simple in terms of uh, memory use and access to method that already exists. So reuse those values. Pretty much is the way how now it works in Java in CSS. So we can also force that by using its inherit property. But it turns out that despite that this built-in features and the inheritance models, CSS essentially, when it comes to describe and resolve competing CSS rules, it uses now the cascade model. So this cascade, which is now made of several tiers, that on each tier, the lower you go into that tier, the less likely are for you to that style to be applied in the document. So it means that the first tier is if you have now an important or transition property. The other now is based on where it is used, where it was defined. This rule, it was defined as by the application or by the user or by the browser, this user agent style sheets, right? Then it's going to now look at the uh, selectors, right? So these competing selectors, if they have now the same, these competing CSS styles, if they have now the same selectors, that's going to break down into something that we can determine that, which is if you have now an ID, that's a higher preference. Or if you have now a pseudo, a class or attribute, if you have a class or pseudo element that has lower priority, if you now select your elements via attribute or via pseudo elements, that has even lower priority. And last but not least is where this uh, CSS rule was defined. If this CSS rule now for some reason is defining at the last of the document, there is a good chance to be override or to apply here. So if you define that on top of the CSS file, it is less likely that this CSS rule will be applied, right? Again, all of this is describing as this cascade. It is important at least to understand how the things work, but it turns out now in the modern web development, uh, some folks might say that this is quite irrelevant, but I do find that understanding this will open up now is your understanding of how CSS actually truly works. So when it comes to understand now the the CSS, uh, especially when it comes to render content and the box model. So when it comes to render content, because most of this come from the print media, by describing is how all of these different elements are gonna be read in Western culture. So you have now is the left to right, and which is the inline direction, is following is the flow of how the line of how the text is read, whereas the block is now a composition of all of these different words into a paragraph that are now going to stack below that, right? So because now in the browser wasn't conceived to be widely adopted by the entire world, all right? So most of the time it was designed similar with the Unicode. It was designed to show content is for the um, Western cultures, all right, from left to right and top and bottom. But when it comes to now show content or render content from Arabic language, all right, that they go from right to left, uh, top to bottom, or from hand-based characters where they now read that inline, so read the content is from top to bottom and from left to right or right to left. So because of this, and the sales pitch here is, well, because we have all of these variants now, it is much more convenient that instead of using is the padding, margin, and bottom properties, which is part of the box model, we use is the logical properties when it comes to describes the direction of the content, right? The block and inline directions. So knowing that, okay, knowing the block and inline directions, um, when it comes to describe how CSS actually look at this kind of elements that we put on our document is as a box, and this box, which is like set of it is a set of layers around the content, where you have now the padding, the border, and the margin. You can think of this like a winter layers that you put on when you do a winter walk, all right? So now the content is yourself, and the jacket, for example, the padding is the fluffy content that keep you warm, okay? The border is now the thick material that is made the coat, whether it's polyester, crayon. I don't recommend crayon because it's highly inflammable, but in any case, and then the margin, right, which is the space that all humans must have. Some people say that is like 2 meters, right, to make you to be safe. So walking through each one of those is to say, hey, the padding, which represents is how you can now add padding to a particular content, it behaves in this way. So you can also is now following is the shorthand rules to make it convenient to that. And remember, if you define several of these declarations, and the last declaration is going to be override previous one, especially on padding or in any rule of that. This is why it's important to understand now this the cascade, all right, and how competing CSS declarations are going to be applied to the DOM, right? So also we look at some couple examples of that, of how now the padding is being added to, and when it comes to, and something important to mention in the box model is because traditionally the width was determined by the content, all right, which can be quite counterintuitive because then the browser add now some padding and border and margin to that, which make it hard to truly compute is the width of that box. So we can now add this particular rule to say, hey, to all of these elements, I want you to apply is the box border box or the box sizing as the border box. So now it's going to include in the width is the content, the padding, and the border. And talking about the border is unlike padding or margin where they have now a specific way of defining it is value. So in border, the only default or the only value that is needed is the width. Okay, so it has now particular anatomy. Your first define is the width, the style, as well as the default value. The only value that is needed here in the border is the style. So this convention is that, hey, I'm going to apply now is this I'm going to or the the format in which you need to define is the border is by saying, hey, this is the padding. Jesus, this is the border style, border width, the border style, uh, followed by the border color, right? And now, how by defining is this? And because you can also define is the corner around this box using the border radius, which is one of the mistakes that CSS say, hey, you know what? We want us to we regret. We definitely regret that. Okay, to call that. All right, so I'll be right back. All right, and here we're back. All right. So by describing is the pattern, the border, and now how the border we can specify is the border radius or the corner radius to be more specific, which is one of the issues that the errors that CSS spec the working group say they regret to make that. Okay, but despite that, we also have another property called outline. That outline say, hey, this is something that is not going to be calculated on the on the box model. Therefore, they're going to be included in the computation, in the calculation, which is something quite interesting because now outline, since it's not being included in the calculation of the box, which is the way how you can define is the position and the geometry using the layout algorithm. All right. To me, it's quite interesting. So, who is calculating that? Who's defining that? And that is, well, there are now certain property that are promoted by this GPU or that are promoted by CSS to be computed by the to be computed and to be calculated by the CSS. So for example, here, when you do is this, well, this is how you can do this. Now, because it means that so outline, for example, in MDN CSS. Okay. So since outline, which is something that is quite recent, quite new to the language, okay, is not part of the box model, the outline will be invisible for many elements if its style is not defined. This is because the style defaults to none. A notable exception is input, which are given default styling by browsers. Outline is a line outside of the element's border, and unlike other areas of the box, outline don't take up space, so they don't affect the layout of the document in any way, which is quite interesting. There are few properties that affect an outline appearance. It is possible to change style, color, adding and width using the outline property, the distance from border using the outline offset property, and corner angles using the border radius property. An outline is not required to be rectangular, while dealing with multiple texts, or while dealing with multiple line, some browsers will draw an outline for each line box separately, while others will wrap the whole text with a single outline. So assigning an outline a value 0 or none will remove the browser default focus style. If an element can be interactive with it must have a visible focus indicator. Provide obvious focus styling if the default focus style is removed. And this is here why, for example, understanding success criteria of focus visible. The thing here is that despite reading all of this, okay, and the benefit and so on and so forth, styling form control with CSS revisited, right? And how you can add this kind of stuff. So button checkboxes, disable form control. So it's actually telling you how to add in those style to that, right? This is disabled like this. So this is the button, submit button, single line. You know, all of these are disabled. Multi-line text input, all of them are disabled, right? It's providing now some examples of how the things works. All right. Perhaps most of them are quite old. Disable form, field set, file, legends, so on and so forth. Text area, multiple text area elements. But it's in here that is describing is how you can do that. Interesting. 4, 5, 6 beret state. 2003 to 2020. Roger Johnson. Powered by the power of HTML, CSS, and 11D. There is a sitemap. You can also subscribe here. Ah, wow, this is quite all stuff. And I do find that I think he made that, but it's because they have a lot of problem back then. You know, after spending a lot of time debating with myself whether I should put some time and energy into creating and maintaining a personal website, I have this finally decided to go ahead and do it. So, yes. Roger Johansson, front-ender, gamer, web standard accessibility and usability promoter, CSS, GS, and HTML. Right? That's quite interesting. The last tweets what's in something 2020. And as you can see, this one. So great. Alright, so great. So now, this is quite interesting. This is also quite old article. Posted in January 9, 2007. But it's because they create this since they have now problems back then. And that is quite interesting. That is quite interesting. That he's using is now Elemently here. Elemently is a simple static site generator here. Interesting here. Very interesting here. Static site generators. Very interesting. Elemently 2024 in review. Very, very, very interesting. Is now increase the number of downloads similar to the star, to the dependent, and the star in Mastodon friends and Blue Skies friends, and the subscribers, Discord member as well, and newsletter subscribers. Holy French though. This was in 2024, 2023, 2024. Okay. And that is because, hey, you know what? We need to find a way to make this stuff easy to go with. You know, easy to go with. Despite that, all of these things that they use in for convention, especially yada yada yada. But it's about this. Okay, from the community, Dana Burney. Mm-hmm. Gold sponsors, silver sponsors. And exact. Most of the time, all of this come from bets. And the plugin and the supporter here. A simple site generator transform a directory of templates of varying type into HTML. And that's it. And if you want to put that or mount that, pretty straightforward. No for scary things, no, it's just simple. Very, very simple. Permanent layer collection content dates, using data templates, interesting data cascade, JavaScript data files, and template language that it supports. Interesting HTML, Markdown, JavaScript, yeah, blah 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 blah, and ignore files, and all of this. So again, the idea is just to describe that, uh, and so get a sense of what it's doing with the outline, the border and the outline. So when it comes to understanding now the way of how all of these elements are placed by the CSS, okay, which is using the flow layout, uh, we look at since the since since CSS is made of it's like since CSS is a set of mini language that is more than a formal language, because you can now specify that each one of those elements behave in certain way. It's going to show elements in certain ways, known as the layout, and this layout will be using is the layout algorithm to calculate that, right? So we have now several of these layouts, whether it is the uh, flexible box, all right, or whether it is grid, okay, aka grid, or we have now the normal, or the normal flow, which is describing here, you know. But it's because of that. It is because the CSS has a several collections. It's more like a collections of mini language uh, than a language that makes a single cohesive language. And it is all about is the way how now CSS is going to treat elements, or the way how now CSS is going to calculate is the layout per element uh, by the layout algorithm, so by the engine. So they are known as the layout mode. So this layout mode that is indicating how this layout element will look like and how it's going to be computed, right? Whether it is, so far is 7 distinct ones, but we have is now the flexible box, right? The flexible box. We also have is the grid, okay. Uh, we also have the position, but for now let's going to focus is on the default one, which is the flow layout. This is something that so this is the default mode. So everything that we have seen so far in this is the document flow layout, which is made of two type of flow layout. So it can be either is inline elements or exactly inline elements or block elements. So because each one in the flow layout, okay, so in the flow layout we have these types of elements that we can have here, this which is determined by the layout algorithm, where you specify is the layout of this HTML element, which can be flexible box, it can be is a grid. In our case, we're discussing is the flow layout, uh, which is made of these inline and block. And these inline elements, by default, there are certain specific elements that applies to. So, for example, is that spans exactly. So, for example, spans or paragraphs or span or paragraph, or even some technical elements like the video canvas. Exact. So like the video canvas and what is the other one? Yeah, the video canvas and image. Okay. So this is one type of layout in the flow layout, and the other is the block. All right. That blocks are now using for things like link is another one. Are using for things like headings, paragraph, footers, and asides. Right, they chunk of content here. So if you want to now use one of this, we can go is with this one. Interesting. But again, you have block and inline elements, and also another third one, which is the inline block, which is the fusion between them, right? So there's also no coincidence that the block and inlines actually follow the directions of what we mentioned before, and how in inlines element don't want to make a fuss, which is inline we're going to behave like polite guests in a party where they're gonna sit where they belong, okay, seats next to each other. So the content is gonna be the place from in that inline in the flow of the in the flow of the in how the content is read. All right, you can now add in some margins by moving it vertically, but you can modify it is width or height. Okay, whereas because mm-hmm, and because now some of these elements, for example, like image and video and canvas, are known as replace elements. They can actually is modify is the width and the height. So the way to think of this particular elements is that they are not special objects you can work with. And the other is that when you're using now blocks elements, okay, blocks elements actually they don't share. Okay, so block elements when you define, they are going to take all the available space in the horizontal, all in the width. All right, so you can also is now fit the contents of this by saying things like, hey, I would like to now take only the available space here, okay, or fit the content here. And by fit the content, you say, hey, I want the width, I want the box model, the box including is the border, is now fits here. Okay, this is when you define is the width. Okay, but it turns out that is actually indeed the element in itself when you when you define this as a display, or in this case, headings, padding, paragraph, footers, and asides are elements. Exactly, are elements, um, are block elements. You just say block, okay? Or you can also define something like this by defining block. It means that because we also see that with margins, there are now special stuff that we can say. So for example, by saying is margin, and when you are trying to apply is the property auto, it say, hey, I'm going to take now the available space in for that property. So if you say margin dot left and you say auto, it say I'm going to take all the available space here, right? So the margin, the left margin that I'm applying here by using is the auto is saying, hey, take all the available space here, all right? And now the width of this content, or now the width of this box will be is fit. I just want it to fit that content. And this is why, for example, when you apply things like margin auto, it's actually centered that, because the auto property is telling that. The auto property is telling, hey, now take for both sides the available space in the left and the available space in the right, and therefore what it's doing is that now the layout here is going to be calculated into the center. So this is why margin auto it is calculating is that when you say auto for that. Another thing is that, for example, if you say something like this, you say, hey, take all the available space here. So that's what you're telling here. Hey, take all the available space here. Or even you can also things like this. Hey, take all the but again, this only works for certain properties here. But in any case, the point that I want to make here is that, okay? So how you can now use is the block, and how when you use the width, you're referring is to the box model, and how when you use now the displayed, you're referring is how these elements are going to be, how the layout of these elements is going to be calculated, right? So normally we have is the flow layout. So far so good. There is no any trouble, any drama here. Okay. So inlines, they don't want to make a fuss. Block, they don't share. It takes all the available space. And inline elements have some magic space because the way how the browser treat is these elements, which is mostly by which is mostly like typography, right? And we have now things like magic space that is adding, for example, when you wrap this into a inline elements, okay, usually image, okay, and how you can actually override that by saying, hey, line height please be 0, okay. And the other is a space between element when you define these inline elements, which is something that by default in the flow layout is doing. So you don't have this kind of stuff in flex layout. Makes a lot of sense. Makes a lot of sense. And the inline elements, they can be wrapped. So inline elements can now wrap the content here. So no matter if this content is overflow, it's going to wrap all of this without us having to be explicit about it. And the other is to deal with the inline block, because with inline we can mutate we can modify its dimension. Okay, in inline block, in fact, it's like a blend between the block and the element on the inline, which is like a inline or like block in inline's clothing. It's like a sheep in wolf. It's like a wolf in clothes, a wolf in lamb's clothing, a wolf in sheep clothing. And it is because when you have now an inline elements, it's gonna behave so you cannot modify its dimensions, all right? But the line cannot be wrapped here, okay? So inline block doesn't line wrap, but it makes a lot of sense. So you are telling to these elements to behave like a block. You can manipulate its dimension here, okay? But when it comes to wrap context in a domain, in a specific width, unfortunately, you're not going to, so for example, like this, unfortunately, it's not going to wrap this content. So if you say something like, if you say something like this, all right, it will say, hey, good. No matter how this width you calculate is, no matter how this width you calculate it, all right, it's gonna be all the, it's gonna take all the available space. Okay, so width is not, so yeah, so width doesn't impact here. So the width doesn't impact here, all right? But for some reason, if you put now a longer text, it's going to now line break that, right? And that makes a lot of sense. And it's going to line break is per word, as you can see. So this particular nuance that might be quite silly to understand and to work and so on and so forth, are just basing, are just lay out the essential of now how CSS works behind the scene, and especially why this is things like a, like it's not like a language, but it's more like like it's more like a set of mini language that make a cohesive one. And this is because how the layout is calculated in this different layout modes. So makes a lot of sense. Makes a lot of sense. Okay. Makes a lot of sense. Okay. So now we are here on the width algorithm and the height algorithm. Alright, let's take, I don't know why this doesn't mention about that. Yeah, no problem. Yes, it is. Alright. So in the previous lesson, we learned how block level elements like H1 and P will expand to fit the available space. And it is easy to assume that this means that they have a default width of 100, but that wouldn't be quite right. Not at all. 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 Exactly the width algorithm. In the following playground, try to toggle the width 100, because again, the width algorithm is calculating is based on the box model. That's the TLDR of all of this. You know, is calculating is based on the box model. So for some reason you say this, all right. So not only that is going to be, the width is like this, you say with 10 pixels, right? Mm-hmm. So you are saying here is that, hey, um, the width of this element, all right. So for example, you say something like this, is gonna align all of this as it is, right? Because that's what it is. So it means that uh, because the width algorithm is now used to calculate is uh, the box model here. Uh, that's what it is. So when you are using now, for example, percentages, those percentages are gonna be based on the pattern model here. So for example here, when we enable with 100%, we cause the heading to pop up outside of our frame. This happened because of the left margin. When we use percentage based width, those percentage are based on the parent's element's content space. Mm-hmm. When we use percentage based width, those percentage are based on the parent's element content space, are based on the parent content space. If the body takes tag makes 400 pixels of the available space, any child with 100 width will become now 100 wide. So this is something that we are aware. I am aware of this. So this calculation happens first before the margin is applied. Both elements have a default width value of auto, not 100%. And auto say is that takes all the available space here in this element. With auto works very similar to margin auto. It is a hungry value that will grow as much as it is available to, but not more. So if we say, for example, auto, you're saying, hey, you're gonna take all the available space for this element. Okay? It is a hungry value that will grow as much as it is able for this. In the case above, our H1 will grow to fill the container minus the 60 pixel or left margin here. It is a subtle but important distinction by default. Block elements have dynamic sizing, so they are context aware. And the keyword values. Broadly speaking, there are two kind of values that we can specify for width. Measurements 100%, 200 pixels, 5 rams, or keywords, auto and fit content. On the width algorithm. Measurement-based values are either completely explicit 200 pixels relative to the parent's available space. Exactly. Keywords are on the other hand, let us specify different sort of behaviors depending on the context. We have already seen how auto will let our element greedily consume the available space while respecting any constraint. Let's look at some of our other options. Mean content. When we set the mean content, okay, and this is understanding is how these values are being calculated, the width algorithm. Okay, when we set the width mean content, we're trying that we want to our elements to become as narrow as it can based on the child content. This is totally different perspective. We aren't sizing based on the space made available by the parent, but we're sizing based on the element's children. So this value is known as intrinsic value, while measurement and auto keywords are extrinsic because the auto is now a hungry value that it grows as much as it's able to, but no more. It's filled the available space there. This value is now an intrinsic, and the while measurement and auto keywords are extrinsic. The distinction is based on whether we're focusing on element itself or the space made available by the element's parent. Here is an example. So we got is this when we say Exactly. So we got is this when we say, hey, I want you the content of this element be the minimum. So no matter the size of the content here, that'll be the more okay. That'll be the width of this element. hmm Okay. Mean content. Good. 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 So here's an example. In this case, we went up with a very narrow heading because it chose the smallest possible value for width that still contain each word. Whenever it encounter white space or hyphen words, it breaks into a new line. For example, like this, right? But if you have that, like as it is. But this is if you want to now fill this content to say, hey, children, I'm going to now take is no matter how small this element will be, I want to take this smallest element as the width of that content here, of the children here. Where now as the max content, it word the similar, but it takes the opposite direction. It never adds any line break. Interesting. This will never add a line break without it. And as you can see, an element with width and max content pays no attention to the constraints set by the parent. It will size the element based purely on the length of its unbroken children. Why will this be useful? Well, if it produces a nice effect when the content is sure to fit within the pattern. But it is all about the content here. These width algorithms are based upon the content, whether it's on the parents or on the children, but it's based upon that. Like with auto, max content doesn't fill the available space. If we add, if we want to add a background color only around the letters, this will be a neat way to do. Of course, we need a render correctly across screen of all sides. We can assume that the container will always be big enough to contain the heading. Thankfully, one more value is provided by the browser, which is the feed content. If this keyword were bowl of porridge, feed content will be the one that Golic, Golix declare just right. Golix. Golix. And the three beers. Golix. What? Golix. The story of the three beers. Okay. The story of the three beers.
Once upon a time, right on the edge of the forest, lived a golden-haired girl. This golden yellow-haired girl's name was Goldilocks. She had such
Goldilocks. Goldilocks. Okay.
Goldilocks.
Goldilocks.
She had such amazing and admirable locks that everyone who saw her was mesmerized. But despite her sweet...
Okay. Goldilocks and the three beers.
What? Please stay in the backyard and don't go into the woods. Deep into the forest in a shack lived porridge for breakfast. One morning, Baby Bear woke up earlier than usual and wanted to eat his porridge. But it was too hot.
Mama, can we go out for a walk in the woods until our porridge cools down?
Mama, Papa and Baby Bear playing in the same yard all the time, and she was very curious about the deep parts of the forest. When she got tired, she stopped and looked around.
What a beautiful forest!
In the meantime...
Okay.
Incised,
They
and
they,
one
they
small.
call this.
Too hot. It's exactly the way I want it. So she ate all the porridge in the smallest bowl. When she was done with her breakfast and felt full, she wanted to sit on one of the 3 chairs in front of the chimney to rest for a while. One of them was very uncomfortable. Finally, she sat down on the small. Goldilocks found herself on the floor and she did not know what to do. First she tried the big bed. This one was too big for her and also too hard. And it was very comfortable, so comfortable that Goldilocks fell asleep right away. And Baby Bear just could not wait to have his porridge. When
Somebody tasted my porridge.
Mama Bear also looked at her
Okay.
bowl. Somebody also tasted my porridge. And when Baby Bear looked at his bowl, he began to cry.
That somebody also tasted my oatmeal porridge. Not only
Look,
The bear
Ah, okay. It's because I never was exposed to this
that
kind of
is
story.
still sleeping in it.
surprised to see a little girl sleeping in the bed.
what is a little girl doing in our house?
She went out of the house and she saw her parents coming across.
Oh, Mummy!
As she promised, she always listened to her parents and did nothing without having their permission. She was a well-behaved and kind girl forever.
The Goose Girl. Once upon a time.
Oh, okay. Is this
You
kind
will be
of
accompanied.
okay, fairy tales. Good. Goldilocks and the 3 bears. Interesting. So if this keywords were ball on porridge, fit content will be one of the Goldilocks declared just right. Here's how it works. Like min content and max content, this width is based on the size of the children. If the width can fit within the parent container, it behaves just like the max content, not adding any line break. If the content, not adding any line break. If the content is too wide to fit in the parent, however, it adds new line breaks as we need to ensure it never exceeds the available space. It just behaves just like the width outer. And then you have now the min and max width. Another keywords, another computation. Okay, all of this is talking about is the width algorithm. And then you have the min and max width. So when we min and max width is say, hey, this is the constraints that we're gonna put here. Okay, this is the constraint that we're gonna put in this box model. All right. However, we can now is center this element as it is. Right? So a thought experiment. This is also to see how you can actually is now fit this into the problem here. Exercise max width wrapper. Frequently, I find myself in a situation where I want to constrain an element to sit in a center column like this. In this exercise, we'll build a generic utility class that we can drop in to solve this problem. Whenever we encounter it, specifically our goal with a max width wrapper is to fulfill this constraint. If it fills available space on a smaller viewport, it sets the maximum width. It fills the available space on a small viewport. Exactly, the small viewport. It sets a maximum width and will horizontally center itself within the parent if there are leftover space. It includes a bit of horizontal breathing room so that its children are pressed right up against the edge to the viewport, but it fills the available space on smaller viewport. So it say should have a mean width of 360 pixels, should have 60% of the breathing room on a smaller screen, and hint some HTML change might be necessary. Feel free to tweak that markup. So what we're saying is, hey, the content, all right, in this case, we need to understand what do we want to do. So should have a max width of 350 pixels. Okay, should have a 16 pixel of breathing room on a smaller screen, and hint some HTML changes might be necessary. But should have 16 pixel of breathing room of smaller screen. Okay, so this is the max width of 300 pixels. Okay, and it must have this particularly margin. Yep, and it must have this particularly a margin on both sizes. Mhm. So it fills the available space on the smaller viewports and set a maximum width, and will horizontally center itself within a parent if there are any leftover elements. So this is the box. If we attach now a card, we say a class, we say, hey, I want the width elements of this box takes all of that, all right. But if I do that, if I say car, so if I do that, what I want is to say is this is the max width, and I want to now center that by using its margin, right? Should have a 16 pixel of breathing room on smaller screen. It should have a 16 pixel of breathing room or smaller screen. Okay. So first is for greater screens, we have that. So we have say, hey, max width is 350 pixels, right? Which is that. If I want to indicate that I want to center this element by using as a margin, you say, hey, margin, please center this in the middle. In other words, takes the available space in the right, in the left, and in the right, and now center this, right? And the other is that should have, okay, and here, and the other is that should have is some HTML changes might be necessary. Feel free to tweak the markup. And then you say should have a 16 pixel of breathing room on smaller screen. Mhm. So on a smaller screen, okay. So this is what it's gonna behave normally, okay. But on a smaller screen, I want you to have is this. I want you to say this, but margin 0, top exactly, in both sizes, right? So this is top and down, and this is left and bottom. top and down, left and bottom. Exactly, it's something like this. Exactly, it's something like this. It is something like this. Hey, if you have now this is smaller, I want you to have at least this. All right, or well, now that. So because now they are competing with the style here, because now they are competing here. Here we can say is um, media query, and I'm not sure what is media is useful. Media query CSS. Exactly, on hover, print, and max width is this one. So you can say, hey, media, and you pass now one way is this. Say, hey, if the media, the max width is less than 3050 pixels, okay, then the class that I want to apply is this, right? Say this, and margin will be like that. Oh, because it must be in this way. Oh, okay. You can say is whether it's the width like this. Is the width is less or equal to 350? I want you to apply this rule, right? I don't think that this is working. It's not working. And it's not working because it must be like this, right? That's quite interesting. So if width is less or equal than that, okay. Many range features can prefix it with min and max to express minimum condition or maximum. For example, this CSS will apply styles only if browser viewport is equal or narrow to this. So if the max width is that, apply this to the min width, right? And it doesn't apply that style, which might be quite interesting. Yeah, it's like not applying that style. It's like no, not applying that style. Some HTML changes might be necessary. You can see is displayed block. Alright, I want you to behave that as a block. I don't quite follow.
So we have this card, and right now this card is hugging the sides of our viewport, as block level elements will if they're not being constrained. So let's add some constraints. And I'm going to start by trying to add a max width wrapper class to this card element though.
Oh, create a max wrapping car to this. So if you add that to this. Okay.
We already have. So I'll define a new selector for it. And the first thing I'm going to do is give it a max width. Then you would probably want to use it does margin trick to make sure just use margin 0 auto, and that would indeed be less typing. The problem is that it sets a value for top and bottom margin, and maybe that's not what I want. Maybe I do want to have a non-zero value for one or two of those sides. So, you know, this is the least impactful way to do what we want, so that's usually a good thing. This looks pretty good, but there is a problem with this, which is when I go back to smaller screens, once again, we do see that it is hugging the edges of our viewport, and that's not what we want, right? One of our constraints is that it should have a little bit of breathing room. And we can try adding this with some padding, but it's not actually going to work for us. And the reason for that is that we are adding the padding to the card.
Exactly, we are adding the padding to the card
Element itself, and if we
exactly, we're adding the padding to the car in itself. But if we do something like this and we say, hey, let's go into our add this margin, say margin in both directions 0 but 50 pixels, right? When you screen this, it doesn't add that as expected. Oh, and it doesn't add that as expected. Because this definition, the way how this impact, okay. So, you know, I'm guessing. And when I do the kind of thing, it's because I don't understand it.
we pop over to the CSS tab, we see that we have some cosmetic styles here. It already has padding, so all we're really doing is reducing the space inside this card, when what I want to be doing is adding the space outside the card. And I can't use margin because I'm already using margin to center this card. So this is the reason for this hint. We can't really do this in the way that we've done it here. There might be ways, but the simplest thing in my mind is to just create a wrapper that does this for us. And when I do that, right, so now the parent is the one that...
Exactly. If you wrap this inside of a container like this, yes, you do. You can say, hey, this will be now the class of this, and therefore is this one. So if you wrap this content as it is, right, you effectively are saying, hey, yes we are, yes we are, yes we want, okay, yes we want And when we add the car here, a margin in both of that direction. So now we're able is to get that.
That is centered, that wraps this card, and that has that inner padding. You don't see the padding on larger windows, but when you get down to these smaller sizes, we have a minimum amount of breathing room, and this works pretty well. Incidentally, this max width wrapper utility, I find myself using this all the time. So whenever I have an element that I want to center, especially in a component world with React, it's just so nice to be able to drop this utility around something and not have to worry about whether the parent is using Flexbox and essentially tweaking the CSS based on its environment. I have a portable way to create a centered wrapper, which comes in really handy.
Mm-hmm. Yeah, it's an affordable way to create centering elements here. Okay. But it's adding now is this. So if I do this, I of course I modifying is the elements in itself of the car, or you can have is now a nice little wrapper here that say, hey, let's go to now add some padding here in both of these dimensions. So by using is this and wrapping that into a element that behave like a block, all right, you can now specify some min width, all right, that it must, or some max width that it must have, and then center that element if you do. A bit too small. In the solution code above, our max width wrapper class has a max width of 350 pixels, and then we're applying 60 pixels of padding of each side. This means that the car itself can only be 380 pixel wide. This is because of the border box sizing. Then 300 pixels width we set includes the bordering and the padding. This might seems like a problem, but honestly I am not worried about it. In a realistic scenario, we probably want to adjust this math width value based on the content anyway. I choose 300 pixels because it is displays nicely in this course platform. Some students have thought to switch box sizing to content box so that 350 width is applied to the inner content side. This doesn't indeed ensure our car will able to expand 350 pixels, but in my opinion that's not a trade worth making. Switching box sizing values between elements is a recipe for confusion. And then you have now the figures and caption. The figures HTML element is a fairly niche but super useful. It allows us to display any sort of non-typical content, image, videos, content snip, widget, etc. It also let us caption that content with fig caption. Here's how it is used: figure, image, and fig caption. Oh, but this figures and caption. Figure elements are block elements, which means they fill the available horizontally space. But what if we want them to shrink, to wrap around the image inside? Oh, because image technically will take all the available space there. Because image is going to take all the available space there, it say, hey, this content is this width and this content is of this width. All right. And it's going to take all the available space here. And the same for this. Different figures will need to be different sizes based on the width of the image inside. Therefore, your solution shouldn't hard code any pixel value. Give it a shot. So because the way how this width algorithm is gonna compute it by say, hey, I want you to take all the available space here, and since figures are now take all the available space in width. So if you say fit content, is to say, hey, make the make the width of the figure here, make the width of that figure, which is a block element, is going to take all the available space. In this case, be fit content. Therefore, it's going to take that as it is. The bigger the content it is. So far so good, right? This might not what we want. We want indeed wrap this as it is, okay? So what we can do is to say, what is the, okay, in this children, what is the maximum or the minimum content dimension here? And based on that, I want to now is expand that element. I want to take the width of that element. So if I say mean content is going to take now is the mean content is going to take now is, okay, the minimum element here. Exactly. So if you say now max content, it's not gonna make any line break, and no matter the length of any of these children content, it will take all the available space. Okay, where in the mean content it say, hey, in each, what is the minimum width? This is part of the width algorithm. Okay, this is part of the width algorithm. From all of these elements in, you have this padding element, and all of these elements here, which one of them has the minimum dimension? And that's interesting because if I don't put it, or this, it will take now is the minimum element here. What is the minimum element in the children content? So in this case is this word, like Barcelona, followed by comma, or photograph here. Again, it's taking now look at the text. What is the mean width of that content based on words? But because here you're specifying is the width of this, all right? So the mean content will be is that particular content that fits that image here. Mm-hmm. And I do find that this is quite...
So the figure element is a block level element, and like all block level elements, it's going to want to expand and greedily consume all of the available space, and what we're left with is this kind of not very nice looking effect. What we want is for this border to kind of taper along the image and be as small as it can given these variable sized images. And of course we can take a look at what we can do. If I was just to give it a fixed width, if I was to say a width of 300 pixels, it's not really going to work because these images are different sizes. So what we have to do is use the min content keyword. That's the magic trick for this solution. And I want to talk a little bit about why that works, because it's kind of weird.
This is the mean content. No, the thing here is that it's pretty straightforward. It's pretty straightforward because it says that this pattern element, so this element, if it, I want to look, the layout algorithm or the width algorithm, you say, hey, I'm going to look at each one of these elements, this children element, the children content element, right? And I'm going to now is calculate is the width, all right? So the width element, the minimum width elements in this children list, okay, is something that I'm going to now apply as the width of this container, of the figure here. Why is this? And in this case, because we are explicitly telling that style it is, because otherwise it's gonna take that now. And this is interesting because remember at the end of the day, now image is videos. Okay, now image, videos, and canvas. All right, they are technically inline elements. So if they're technical inline elements, they're gonna put okay, because they're technically inline elements, they're gonna put is now the same for this, right? So this image is actually getting that, but in this case it's now taking is this. So because inline elements now are taking all the available space, so they don't make a fuss. Okay, they take all the available space as inline elements, and the width is gonna be calculated is based on the minimum width children elements, and in this case is this image. So now this is why it actually fits this.
When we've seen min content so far, we've seen it in that context of the words stacking one on top of the other. And we can see that dynamic if I change this to fig caption. So now I'm just targeting the captions, and we see that behavior again of like, it's really trying to squeeze these words so that there only is like the longest word represents the total width. So in this case, it's Barcelona. In this case, it's photographer. But when I do it on the parent, when I do it on the figure, it has two children to look at. It has the image and the fig caption. And just like how the fig caption was looking for the longest word, the figure is now looking for the widest child. So in this case, the widest word would be the word Barcelona.
The figure here, when we look at the mean content, is looking is for the widest. Is looking is for the widest element. For the widest children.
That word is, I don't know, let's say 70 pixels, which is quite a bit narrower than the 200 pixels of this image. And so it can't shrink below the minimum width of the widest child, right? So it happens to work quite well in this case. Of course, if the word Barcelona was really long, that's a little bit too long, I think. Well, I've broken my editor, but you can see the effect, right? Like it's having, now this is the longest child, and so it's too wide. But with that little caveat aside, I think honestly this is a great solution, and we can consider this one solved.
But again, I do think that this is quite revealing, because this width algorithm that because this width algorithm, which is something that is being used heavily, this width algorithm is something that is being used heavily. That makes a lot of sense. This width algorithm, which is something that is used when it's going to compute is the width of a particular element, that we might think that if you say now with 100% is going to be now the 100% of the entire element, that current element, but the reality is that not. When you're using that percentage in width as unit, it's going to take now the parent element. If you're using now, for example, is some of these keyword, for example, min content, max content, is going to use now the width of the children width, whether it's the maximum width children element with min content, or the max content is say, well, I don't want to break any line here, right? So this content will be as long as it can be. And they also, you have is the fit content, which is now talking directly is to the element in it itself. All right. It's like, hey, now let me now is. So for example, if I say here the feed content is now okay. Feed this content is inside of the viewport here. Feed content now is going to line break that, all right, which is great. Feed content is now to line break that, unlike max content where there is no line break, and mean content is going to take now is the widest children's elements here. Holy moly. Okay, and when you look now at the width height algorithm, we have seen how width are calculated in flow layout, but what about height? In some way, it works the same way. Setting an element to have the height of percentage will force then it to take up the half of the parent's element. So percentage here is based on the parent. Okay, in other words, they're quite different. The default width behavior on block level elements is to fill all the available width. Exactly, is to fit all the available width, whereas the default height behavior is to be as small as possible. Interesting. So, in contrast with width, the height here in auto the default exactly, whereas the default height behavior is to be as small as possible while fitting all the elements content. It is closer to with mean content than with auto. Also, we tend to treat height as more dynamic than width. We might feel comfortable setting our main content wrapper to have a max width of 750 pixels or 700 pixels. Exactly. We might feel comfortable setting our main content wrapper to have a max width of 750 pixels, but we wouldn't usually do this with height. We want our design to work whenever the content is 200 words or 20,000 words, or even for page with exact same content. We expect that our containers will grow taller on phone screen and shorter on desktop monitor. We generally want to avoid setting fixed heights, otherwise we might wind up in a situations like this, where you say, hey, this paragraph is breaking. It's breaking out of its box. Because we have encountered, we have constrained the height following is the box model. We have constrained this to 100%, but the max width is 300. Right? So when it comes to layout, wrappers like this, setting a fixed height is usually a bad idea. But what about when we want to set a minimum height? For example, let's say we have an element that wrap around our entire app, right? If a specific page doesn't have much content, the entire app might be less than 100% of our window height. What if we want, exactly, what if we want it to take up at least 100% of the available space? What if we want to take at least 100% of the available space? Exactly. What if we want to at least 100% of available space? Our goal is to have a wrapper element that will be no smaller than 100% of the available height, but mean height 100% doesn't work. Okay, I am not very tall. So have you ever tried to use percentage barrier heights only to discover that it seems to have no effect? Yes. I Again, this wrapper now is a section which is now a block inline, where it say, hey, I am not very tall, so you are expecting to get is now is the patent height here as a wrapper, but it turns out that it's taking is the available space here, the available width, the available height here. So in this lesson, we're going to look at why this happened. As we saw earlier, the default behaviors of element in terms of height is to be as small as possible to contain its children. So this is the default behavior in height algorithm, is to be as small as possible to contain its children. So our section sits inside of the body tag. So when we set the percentage base height or mean height, the percentage is based on the pattern height body. Doesn't have a specific height set, which means it is used the default behavior, stay short as possible, while still containing all the children. In other words, we have an impossible condition. We're telling the sections to be percentage of the body, and the body wants to base its size off of the sections, and they're both looking to each other for guidance. This is a really common source of confusion. It isn't fixed by Flexboard or Grid either. Those tools help us to control the content of a container, but that container still needs to get its height from somewhere. Here's how to fix it. You put 100% height on every element before your main, one including HTML and the body, or you put the main height to 100% on that wrapper, or don't try and use percentage base height within that wrapper. When HTML is giving high 100%, it takes up the okay, it's only when the HTML is giving 100% height, it takes up the height of the viewport. That serves as our base. The body tags 100% is based on that base size. And when we get our wrapper, we wanted to use the mean height. In this way, the minimum size is equal to the viewport height, but it can overflow and take up more space if required by the content. Here is in the code. But it's you specify now that. But because you don't put that now to the body is not going to inherit that, which to me is quite interesting. It's interesting. But if you define that, so hey, I want you to be the 100% height, which is the view height, app wrapper gotchas. JavaScript frameworks like React will render our application into a container element in order for percentage base height to work. We need to add the height 100% to its wrapper. If you use Create React, the wrapper has an ID of root. In Next.js, it is next. Here's an example of how you can solve this problem for these two common frameworks, HTML body, root, and next. Okay, note that this is specific to React. We need to include selectors for every element that sits between the root HTML tag, and that the element wants to stretch to 100% of the screen size. But yeah, I don't want to distract from the fundamental takeaway here, because it is really important. One, by default, width look up the tree, while height looks down the tree. Okay. By default, width look up the tree in a percentage, okay, and height looks down the tree. An element width is calculated based on its pattern size. An element height is calculated based on its children. So when it comes to height, a pattern element will shrink wrap itself around its children, like a pouch of vacuum sealed food. We can override this default behavior by specifying an explicit value for example, width 300 pixels and height 500 pixels. Don't look up or down the tree. But in this case, we don't exactly. By overriding the default behavior, we specify an explicit value. In this case, they don't look up and down the tree. They don't have to calculate anything since we're giving a specific value. So I am specifically talking about when we don't set width and height. You may be familiar with the view unit. A unit is designed exactly for this purpose. If you set view height, your element will inherit it is high from the viewport size. Unfortunately, this unit doesn't quite work the way we often like because mobile devices. When you scroll on a mobile device, the address bar and footer controls lie away, yielding their space to the content. This means that scrolling on a mobile device changes the viewport height. To avoid flickering UI issues, browsers like iOS, Safari, and Chrome will set VH equal to the maximum viewport height after scrolling. This means that when the page first loads, 100 view height will actually be quite a bit taller than viewable areas. If you want to see this for yourself, give a shot on your phone. These days there are new units we can use that don't share this problem, in particular the small viewport height. Okay, will always correspond to the shorter viewport size, the initial condensed viewport. In case where you want an element's height to be equal to the viewport, my recommendation is to do this. Fallback for all the browsers and this one. This unit is available across all modern browsers, but it's still good to provide a fallback for good old browsers. Small view height here. Unit. Exactly. Small view height. Small view height. Small view max. It is still worth knowing how percentage-based height works, since there will be cases where you want to use the padding container size rather than the viewport. But hopefully this new small view height unit comes in handy. But what about the footer? Earlier we talked about the common UI challenge of having a footer that stayed at the bottom. Having a full height container is an important prerequisite, but we haven't seen the tools need to finish solving this problem. Ultimately, the goal of this model is to get comfortable with the height algorithm in flow layer, to understand why height and mean height sometimes don't do what we expect. Specifically, in order to solve this problem, we need to use Flexbox. Flexbox is subject to upcoming model, and we'll see how to solve this and many other problems with it. I know cliffhangers aren't any funny, though here's a solution. If it doesn't make sense to you yet, don't worry. Before too long, you will become the Flexbox champion. So what you're saying is, hey, this footer, which is a footer, by wrapping the entire element, so by saying is that, hey, I don't want you to behave now like a blog or inline, right? No. This is the layout calculation. It's a flex box. It's flexible box. So you're saying is the mean height, which is looking down, okay? The mean height will be is 100, all right? And it's because you are now inherit that height from the top, all right? So because you are inheriting that from the top, because if you say something like this, it's gonna put it there, okay? But if you do things like this, it say, okay, no. I take now all the height from this viewport, okay? So this is the wrapper that is now a flex box, okay? The flex direction will be a column, so all of these elements we're gonna be in this particular position, and since now here the mean the wrapper exactly, so the entire height of this HTML is now the viewport. All right, this is the entire viewport here. So whatever element you put in here, I'm gonna now put it this as a column. As a column, exactly, as a column. So making is the wrapper is 100% the height from the HTML. So for example, you say something like this, it's going to be up to that. And now because this mean height is now based on the height that comes from the pattern, and in this case the padding is something that is passed down to percentage looks upward. By default, width looks up the tree while height looks down the tree. An element's width is calculated based on that. Okay. So the height looks upwards. So the width of that element is looking upwards, and the height of that element is looking as it is children. Okay. It is also possible to solve this problem with absolute position, something we'll see in the Model 2. I do not recommend this approach though. The footer can overlap other content unless you're very careful and use hacky workarounds. That makes a lot of sense. So so the thing here is that width is calculated based on the width look up from the pattern, and height look up for its children. So that value by default is calculated in that. Important is by default, exactly, by default, width look up for the tree, all right, and height look out down the tree in order to calculate that. In order to calculate this unit, that. And then you have margin collapse. Margins aren't overlapping. Too close, margin not respect. Margins collapse. Earlier we talked about how margins is a key in this personal space. Let's suppose that we want to keep 6 feet on personal space, and when we think about it, though that 6 feet can be shared, if each person has 6 foot bubble, we don't actually need to be 12 feet away. Margins aren't overlapping at all. Margin works in similar fashion. Adjacent margin will sometimes collapse and overlaps. This can lead to some surprising behaviors.
So margin has this tricky thing that we need to talk about, which is, unlike padding and border, it is possible for margins to overlap. Say you have two paragraphs, right, one on top of the other, and each of those paragraphs wants to have 20 pixels of margin, 20 pixels of space. If you just put them one on top of the other, you're not going to get 40 pixels between them, you're going to get 20 because the two paragraphs are going to share that margin space. And this is called margin collapsing. It's the idea that when you have margins that are side by side, they collapse into one space. And this sounds simple, but there's lots of little conditions and edge cases that make it actually really hard to develop an intuition for if you just wing it. Taking a little bit of time to familiarize yourself with these rules makes things so much easier and so much more intuitive. And so that's what this lesson is about. We're going to develop an intuition for how margins collapse when they do and don't. And just to give you a quick idea as to how this can be surprising and how unintuitive it can be, I want to look at an example. So here I have, it's just a heading and some text sitting in a white box. And you'll notice that this heading is right at the top of the box, right? It doesn't have any breathing room. So you might think one way to solve for this is to give this heading a bit of top margin. So I'm selecting just the heading, right? Not the container, but the heading. And I'm going to say margin top. And let's give it 24 pixels. And what you'll notice is it's not moving the heading down. It's moving the entire container. If I look at the container in the DevTools, right, it still doesn't have any top margin. If I scroll all the way down here, there's no top margin. So it is the margin of this heading which is pushing the whole thing down. And this is weird. We can make this even more noticeable if I increase the size of that margin. Let's bring it up by an order of magnitude. And now you'll see that all of this space isn't getting between the element and its environment. It's transferring up to the parent. This probably doesn't even seem like margin collapse, but it is, and we're going to talk about why that is.
It's transferring to the parent here, especially with margin. I'll leave that for today's video. So that'll be all. Take care. Bye bye.